Hello, everyone. We have a wonderful day today in Barcelona, and I really appreciate that you came here to see my presentation. I know that we are just about to go for a beer, but I'll try to make it quick, but not too quick, so that you can stay focused. And I'm really enjoying this day. It's a fantastic conference, and I'm very happy to be the part of it. And maybe just before we get into the topic, I would like to tell you a few words about myself, because you probably have no idea who I am. My name is Bartłomiej Słota, and I come from Warsaw, Poland. And believe me that this is not the hardest name in Polish to pronounce. But if you still struggle, you can just call me Bart, if you like. I am a software engineer. I am also a speaker, and I run a blog. I currently work for Agile Tech, which is a pretty young company that is a technology center of Hargreaves Lansdowne from Bristol, UK. And Agile is the largest financial service company in the United Kingdom. And Agile is currently looking after over 86 billion pounds for over 1 million of clients. And what we are doing up there in Warsaw in the technology center is developing software with all the latest techniques, with all those Spring goodies that we are talking about during this conference. And yeah, currently we have around 60 people on board, but we have plans to expand the number of 200. And here you can find some of my contact information. You can follow me on Twitter. You can visit my blog page. All code examples that you will find in my blogs, blog articles, and during today's talk are already on my GitHub account. So you can download it, play with it. And feel free to write me an email if you have any questions or remarks regarding my articles, talks, or whatever. And if you're interested in what I'm doing professionally, you can also visit my LinkedIn profile. All right. The topic of today's talk is dynamic configuration management in microservice architecture with Spring Cloud. It is quite long. The title is quite long, but it tells almost everything about what you will find here today. And during this presentation, I will give you a hands-on example of a simple microservice architecture, which we will analyze and improve in the field of configuration, so that we can finally reconfigure our apps dynamically without the need of rebuilding or rebooting them. And we'll do all those things with the help of the almighty Spring Cloud. And during this talk, I will introduce you to the topic of configuration management. I will discuss the issues that we face in microservice environments. And I will also show you how to set up a config server, how to set up a config client, and finally, how to make use of Apache Kafka in order to dynamically manage our configuration. All right, so maybe let's start with answering the question, why should we care about configuration at all? And well, in the scary world of monolithic applications, we succeeded in working out numerous design patterns and good practices. But when we move towards distributed environments, we should apply them very carefully, especially today when there's hype around microservices, and all software developers around the world will love to create their next project in microservice architecture, right? But there's very often something missing in between, because microservices are not just an ordinary distributed environment. They are something more. Microservices are about to empower us to respond to changing requirements lightning fast. We need to scale, redeploy, reconfigure our applications much, much quicker than ever before. And it seems to be obvious today to keep our configuration outside our code in some external properties or YML files, so that we can very easily locate it without the struggle to find the proper line in code to be modified. But there's also another reason that stays behind externalization. And externalized configuration should enable us to deploy our application on whatever environment we like. Build once, run anywhere. And these are the config files that are the place where we should adjust our application to a given environment. And so that we can finally make our application environment independent. And Spring helps us with this with so-called profiles. Another thing about configuration is that we usually keep our config files bounded with our deployment package. So still, if we need to change anything within configuration, we still need to rebuild or redeploy our applications. And although we can keep some of our files outside of a jar archive on a server, we still usually need to restart our application, and at the same time we lose trace about what's going on up there in the config file. But I will tell you about traceability in a second as well. Another thing in configuration is scalability. If we are in microservice environments, we have lots of services scaled up to a couple of instances, and when we change anything inside configuration, we want to apply all those changes to all instances of our running service, right? So if this process is not properly automated, it can be a very tough task to manage the configuration of a service that is scaled. And it may also be the case that we developers have restricted access to credentials to production databases, some external services. And I can tell you a story from one of the companies that I worked for a couple of years ago, and I think that many of you might have experienced that as well. When we are developing some monster, some monolith, and we are about to deploy the application in production, it required client's administrator to set particular properties just before running the application. And it was our role to provide a specially formatted Excel spreadsheet where we described what properties in what way should be set. And this was the way that we provided security in our case. But at the same time, we had no idea of who changed what and where and when on the server. So we lost completely the trace about what's going on up there. So you can see how complex and confusing configuration management may be. And you can also see that just an ordinary properties and YML file might just not be sufficient. How to solve these problems? I'll show it to you using one simple example. What we have here is an overview of our example that we will be working on today. And what you can see here at the very bottom is that we have two business microservices, customer manager and product manager, that are obviously responsible for managing customers and products. And let's also assume that both of these applications are accessible from the outside world only through the gateway application, which is an implementation of API gateway pattern with the help of Netflix Zool proxy. And with the help of Netflix Zool proxy, we can very easily both route proper requests to proper services, and at the same time, we have one central place where we can manage some common issues like security, request filtering, or whatever else. And on the left, we have infrastructure services. And inside there, we have a discovery server, which is a Eureka discovery server. And all those applications communicate with each other using the HTTP protocol. And I took the liberty of starting those applications just before the presentation. And what you can see here is the Eureka dashboard. And you can see that we have 3 services up and running. We have a customer manager, product manager, and the gateway application. They are all in the up state. We have 1 instance per each service. And what you can see here is the customer manager is running on port 8085, product manager on port 8086, and gateway on port 880. So now let's try and see how they work just before we dig into the topic of configuration management. And because of the assumption that we want to access our environment through the gateway, I will send a couple of requests on port 8080. So let's start with simple. Do you see anything? Not really. Whoa. And what about now? Better? That's a bit problematic for me. All right. Anyway, curl. It's just an example. Products. Yeah. Here you can see that we can get the access to all available products, and similarly we can get all available customers. And what is special about Customer Manager is that we can distinguish premium customers as well. And the premium customers are those who have their email addresses ending with particular email suffix. This will be a configurable property which we'll be playing with today. And in order to get those premium customers, I will add just the premium attribute here. And what you can see here is that we have just one client available here, one premium customer. And yeah, now you can see that all those applications work. So now let's move to the IDE. Now we should see it much better. And I have a multi-module project where we have a couple of applications. The first one is Discovery Server. And the central part of Discovery Server in the pom.xml file is Spring Cloud Start and Netflix Eureka Server dependency. And of course, because we are using Spring Boot, we also need to enable this. We need to use the enable Eureka Server annotation so that we explicitly tell Spring that we want this application to become a discovery server. We also have a bit of configuration here. And regarding the business service, let's have a look at the customer manager here. We have a couple of more dependencies like Spring Boot Starter Web, Actuator, Data GPA. Of course, we have also Spring Cloud Starter, Netflix, Eureka client in order to register our application inside Eureka. And because we are talking about configuration today, let's have a look at the application YML file. And apart from some standard properties like application name, server port, and Eureka client configuration, I have one business property here, premium email suffix, which is currently equal to yahoo.com, which you could probably see, some of you at least, that the only premium customer was the one with the email ending with yahoo.com. And where I'm using this property is a class called customer service, which is annotated with the service annotation, and the refresh scope annotation, which I will tell you about in a couple of minutes. And what I'm doing here is that I am injecting this value through constructor injection, and I'm using it in order to filter all my available clients, just looking at their email addresses and checking if they end with this premium email suffix. It is very easy. And product manager is pretty similar to the customer manager, so I won't waste time talking about this. But there's one more thing I would like to show you is the gateway application. In order to make our application a gateway one, we need to declare a Spring Cloud Start Netflix Zool dependency, and like with most of our application, we need to explicitly enable Zool proxy here. And in the application YML file, I have here some routes configuration. I have some simple path matching patterns in order to tell Zool how to find proper services, where to send the traffic. And because I'm using service names, I'm utilizing client-side service discovery and client-side load balancing. All right, so now you can see that all applications are working. You know what's sitting under the hood. So now let's try to focus on solving the configuration issues that we mentioned at the very beginning. So Spring Cloud comes with a Spring Cloud config module, which provides us both tools, both server and client-side support for managing configuration in distributed environments in a centralized manner. And let's start with config server maybe. And what is the config server? Well, the config server can be treated as a remote property source and can be backed by numerous storage providers like Git, for example, which is the default setting. But we may use SVN or some distributed file system, for example. And we may even have, within one config server, a lot of different providers configured. We can keep configuration for different microservices in different providers. But sticking to the default, to the Git, we can very easily manage configuration for any application in any environment. At the same time, with Git, as you should probably know, we can very easily manage the access control. We get the access control. We can very easily restrict access to, for example, some production properties. And also, what Git gives us is traceability. We have full history of what's going on with our configuration. We know who changed what and where. And at the same time, we also, if in case of any errors, we can very easily revert all those changes. So you can see that just by using a config server with Git as a backing service, we solve most of our problems that we addressed today. We have an externalized configuration. We have our configuration files outside of our deployment package. We have security. We have traceability. The only thing left is scalability, which we will solve in a couple of minutes. All right, so let's try to make our infrastructure look like this. What we have here is that now our infrastructure services will be enhanced with a config server that is communicating with Git repository, GitHub in this case, and all our services are supposed to read their configuration from the config server. And yeah, let's try to do it. Let's move to the IDE, and I will create a config server with the help of Spring Initializer. I hope you are familiar with Spring Initializer. How many of you are familiar with Spring Initializer? Yeah, that's quite a lot. And did you know that the ultimate version of IntelliJ IDE also supports that? I will show you how to do it. We'll add a new module to our application. And here you can see that I'm using a Spring Initializer. I can set here a package name, and let's call our application ACS. I'm using a Maven. I'm not a hipster. Yeah, and what properties? Yeah, what properties? What dependencies do I need here? Because I'm setting up a config server, I will click the config server, and let's add also some actuator. And I would like to keep it to register my application within Eureka. I will also add Eureka Discovery. I will click next, and I hope we have internet connection and my ID will download sources quickly. In the meantime, I'll show you the pom.xml file of our new config server, and the central part of it is Spring Cloud config server dependency, which is the dependency that you always need to declare if you want your application to become a config server. And yeah, it is still starting, downloading some files, indexing files. And because I don't like repeating myself, I will, in the meantime, rename the file. I hate properties. I will use the YML file, YML. Yeah, and like we used to do it, we need to, again, tell our application explicitly that it will play the role of a config server. So I'll use enable config server annotation. And let's try to add some configuration. Well, let's start with some simple one. Spring application name. Let's call it config server. Let's also set up a port number, server port. The conventional setting is 888. And now, because we are using Git as our backing service, we need to tell our application where to find our repository. And I prepared such repository on my GitHub account. It is available there, and we will use it over here. And in order to set up a Git repository here as a backing service for our config server, I need to set this property: Spring Cloud config server git URI. And the repository is located over here: https github.com/bslota/config repository.git. And there are plenty of configuration possibilities here, but I'll use just a couple of them to show you how we can utilize it. And the first thing I would like to set is clone on start property, which is by default equal to false. I will set it to true. And if I set clone on start to true, my server will download the configuration files eagerly during the server startup, and it will, of course, increase the booting time of our server. But right after the startup, I will be ready to serve configuration for all other services, not influencing their booting time. So one more thing I would like to set here is search paths. And search paths is the property that tells our config server where exactly our config files are located within our config repository. So I have the following folder structure over there: config/application, and you can application. And what you can see here is that I'm using a simple placeholder. I'll tell you about placeholders in a second. But because I want this application to be consistent with our infrastructure, I need to also register it within Netflix Eureka. So I will copy the configuration of our client from one of the applications here. I will copy this part and paste it here. Yeah, and the concept that stays behind the config server is remote environment repository. You should already know what environment in Spring Framework is, but what is this repository? Let's open a file called environment repository. It is here. Let's download some sources. And what you can see here is that this is a very simple interface that tells us a lot about things are organized within our config server and in the backing service. And it defines a way of properly identifying the environment that we are looking for. And like you can see here, is in order to properly identify the environment, to get it, we need to provide three things: application, which is our application name; profile, which is currently active profile of our application; and label, which is an additional parameter used by the backing service. And in case of Git, it can be a branch name or a tag name, for example. And each of these three variables can be used within our configuration in order to choose a strategy about where we store our configuration. And what you can see here is that I have one common repository for all applications, and I'm storing configuration in application-dependent folders. But using the application and the profile placeholders here and in the Git URI property, we can very easily choose, for example, one repo per profile strategy or one repo per application strategy just by using those placeholders here inside the configuration. But they only this is not the only role that they play, because they define also the REST API, which our clients will use in order to get their configuration. And here you can see the endpoints that are published by the config server, and you can see how many different possibilities we have to get the configuration of our service. There's plenty of options, plenty of combinations of our application profile and label placeholders over here. All right, let's get back to our IDE and try to run our config server, and let's hope it will work. Yeah, if you're doing live coding, there's always a possibility that something will fail. Yeah, and it did. And what we did wrong, no idea. Maybe with the port. Yeah, server port. So let's rerun it. Yeah, it is starting now. Yep, it seems to be fine. To be sure, I will open the Eureka dashboard again, and you can see here that I have a config server application running, and it is in the app state, and I have one instance running of it. But you should remember that the config server is the central part of your infrastructure. It serves configuration for all your applications, so you always need to scale it up for resilience. All right. We have our config repository in place. We have our config server. Let's start utilizing it in our clients. So I will get back again to my IDE, and now I need to configure my applications so that they download the configuration from the config server. And because the configuration will be pretty much the same in all of our applications, I will just focus on one of them, on the customer manager. And in order to integrate with the config server, we need to apply following dependency, which is Spring Cloud Starter config. And before we configure our client, I need to tell you in a few words about Bootstrap context. And the Bootstrap context, in a big short, in Spring Cloud applications, is a parent for main application context. And its purpose is to load and decrypt, of course, if needed, properties from external sources. And it is by default defined here in the Bootstrap YML file. We have currently, this file is currently empty, but we will fill it up. And what you should put in this file is information about how to locate the config server and how to properly identify our environment there. Do you remember application profile and label properties that we mentioned already? These are the things that we need to configure here. So let's try to do it. Spring Cloud config. The first property will be name, second profile, and the last one will be label. And thanks to creators of Spring Cloud config, there are very reasonable defaults here. And by default, Spring Cloud config name is equal to Spring application name property. So what we need to define here really is Spring application name property, which is equal to customer manager. Customer manager. And of course, we no longer need this property being set here in the application YML. Yep, we no longer need the name property here. Profile is by default equal to a comma-separated list of active profiles, so we also don't need it. And the label is evaluated on the server side in the backing service, and if we are using Git, it is by default equal to master, to the master branch. But for the purpose of this talk, I set up a special branch called Spring IO, so I will set it up here. And there's one more thing we need to set, and it is the location of our config server. And here we have two possible strategies. The first strategy, which is the default one, is config first bootstrap. It assumes that we will define our config server URI explicitly, and the config would look like this, config URI. and it is also by default equal to localhost 8888. But this strategy has its drawback because we cannot benefit from the config server being registered within Eureka. We cannot benefit from the client-side service discovery. But we can deal with this problem by choosing the other strategy, the second one, which is called Discovery First Bootstrap. And in this strategy, we are downloading the service registry from Eureka, and then we are trying to find the URI of our config server using the service name. And in order to do so, we need to explicitly enable discovery here. Discovery enabled, we need to set it to true. And we also need to provide a service ID. And the service ID should be equal to the name of our config server application, and it should be equal to config server. Yeah, and this should be just fine. So let's try to restart our application, and let's hope that it will work. Yeah, I'll have some water in the meantime. And while it's starting, I will show you our repository. And this is exactly what I have on my GitHub account. What you can see here is that in the customer manager directory, I have application YML file. And what you can also see here is that I have a premium email suffix property set to gmail.com this time. And because the configuration that is stored in the config server in the backing service takes precedence over the local properties. So now when I send a request for all premium customers, now I expect to get only those who have email address equal ending with gmail.com. So getting back to our application, let's have a look at the logs. You can see here that we tried to fetch the logs from our config server from port 8888. And in the last line, we can see that we successfully located the environment for the application named customer manager, for default profile, and for the label equal Spring IO. I will move now to my terminal. You can see it, so maybe I will do it here. Just give me a second. I will open the terminal here. Tool windows, terminal. Yeah, maybe here. Curl. Yeah. What you can see here is that now, as expected, the only premium customer is bruce.dickinson@gmail.com. So you can see how easy it is to set up a config server, to set up a config client, to integrate with it. And now let's try to make an experiment. And let's change the configuration in the backing service. And let's see how to reload our configuration in our clients. So what I'll do now, maybe let's start with talking about how to do it. The easiest way would be to do it manually. And thanks to the actuator endpoints, we can very easily do many management instructions in any of our application. And in terms of configuration, we can send a post request to /actuator/refresh endpoint. And we can tell our service to refresh, to reload the bootstrap context. What does it mean to reload the bootstrap context? It means to rebind all classes that are, all beans that are annotated with configuration property annotation, all beans that are annotated with refresh scope annotation. And you could already see that we have one bean annotated with the refresh scope annotation. So I expect that after reloading this bean, the property premium suffix will be rebinded. And the last thing that happens during the reloading of bootstrap context is rebinding all log levels. All right, so now let's make this experiment. And I will change here in my remote repository the premium email suffix from gmail.com into yahoo.com. I will make a comment, git commit, and I will make a push into remote repository, git push. And I hope we have internet connection. Yes, we have. And yeah, great success. So what do we need to do now is, just because I don't remember what exact request should I set. I have it here, Carl, localhost 8085/actuator. Sorry, curl -x post localhost 8085 /activated/refresh. Yeah, it's probably hard to see for you. I will rewrite it in the IDE, sorry. Curl -x post localhost 8085/activated/refresh. And the bad thing about this is that what you can see is that I am no longer sending a request to my gateway. I am sending the request to a particular instance of particular service. So the first issue that should come to your mind that we can identify is that if we have numerous instances of our service, it will be extremely hard to control the process of finding those URIs, of sending those refresh requests, of controlling the process of updating the configuration in every instance of our service. So when we send this request, let's wait for the response. And what you can see here is that in the response, we have information that that our service successfully updated the premium email suffix property. So to be sure that it works as expected, let's send the request. And you can see that now the only premium customer is Stevie Harris with the email address ending with yahoo.com. And so you can see how easy it is to provide manual refresh ability. But as I mentioned, it is very difficult to control this process in the microservice environment when we have our services scaled up to a big number of instances. But now I will show you how to deal with this problem. And let's open another slide. And the desired scenario would be that all services whose properties get updated within a push into remote repository get automatically notified about the need of reloading their configuration. And in order to do so, we need to find a way of propagating those management instructions. And to solve this problem, we'll use Spring Cloud Bus, which is a module that was built to propagate management instructions. And it makes use of both Actuator to add new management endpoints and utilizes Spring Cloud Stream as well in order to provide the abstraction over AMQP brokers to propagate those messages through the message broker. And in our case, we'll use Apache Kafka. And now the desired architecture will look exactly like this. And what you can see here is that we are asynchronously informing all interested services about the need to reload their configuration. And I need to tell you right away that if the configuration management is the only reason for you to set up a Kafka cluster, then just don't go for it. It would seem to be crazy to manage a Zookeeper cluster or Kafka cluster in order to send a couple of configuration messages. Then I'd rather go for some lighter solutions like RabbitMQ, for example. But if you already have Apache Kafka in your infrastructure, you have, I know, an event-driven architecture or whatever, you're using Apache Kafka, then just use it. Personally, I'm a big fan of Apache Kafka, and I have it running on my laptop most of the time. I like sending messages back and forth, so you can see that here's Zookeeper, Kafka, and I also have a message broker, a console consumer. So I'm playing with Kafka a lot. And yeah, let's try to implement it. I will get back to my IDE. And let's start maybe with a client side. So let's move to Customer Manager to pom.xml file. And in order to enable configuration management, to enable our application to respond to the request of refreshing our configuration, we need to apply this dependency called Spring Cloud Starter Bus Kafka. And if we open the pom.xml file of this dependency, you can see that we have two transitive dependencies. First of which is Spring Cloud Starter Stream Kafka, which gives us then abstraction over Apache Kafka and AMQP, this kind of AMQP broker. And we also have Spring Cloud Bus that gives us the ability to send management instructions and to listen to those instructions. And we also need to configure it a bit, but because my local Kafka cluster is running on default settings, and those default settings are applied as well in those libraries, I don't need to set up anything, but anyway, I would like to show you what you need to do in order to communicate with Apache Kafka in another way if you're not running it locally. So it will be Spring Cloud Stream, Kafka, bind brokers, and it is currently running on localhost port 1992. And this is what you should set. So let's restart our application. Let's hope that it will work and it will successfully connect to Apache Kafka. Yeah, let's have a look. I'll have some water in the meantime. I expect to see some interesting logs here, which I'll show you as well. Yeah, it's starting. Yeah, and I can see that it's successfully connected to a Kafka cluster. This logs tells me that. And there's one interesting thing that I want to show you, Spring Cloud Bus. And what you can see here is that there's one thing that occurs very often, is Spring Cloud Bus. And Spring Cloud Bus is the name of the topic which we will use in order to propagate all management instructions in our case. And this is a vital thing. All right, so now let's move, because our application successfully connected to the Kafka broker, let's move to our config server. And this time we also have to put some dependencies. I don't have them prepared, so I need to write them down. The first dependency would be Spring Cloud Starter Bus Kafka, and you could Kafka, and you could already see this dependency. But there's also another one that we need to provide, and this time it is called Spring Cloud Config Monitor. And Spring Cloud Config Monitor gives us something more. It gives us a new management endpoint called monitor/monitor, and this endpoint will accept the post request with the information about which service needs to be updated. And it is the role of the config server to propagate those information to all instances of our running service. So this is the way that we deal with the last problem that we identified at the very beginning, scalability. All right. So okay, let's restart our config server and let's see if it works. Let's restart it. I'm always getting nervous when I'm restarting the application live in front of such a big number of people. Yeah, it's starting. It's successfully connected to Kafka. I want to make sure that everything works. I will reload the Eureka dashboard. Yep, everything seems to be fine. So let's make our experiment once again, but this time we will try to call our monitor endpoint. So I will get back here in my config into gmail.com, and now our premium email suffix will be equal to that. Let's make a commit. Let's make a push to my GitHub repository. Yes, we have internet connection. Yep, and what I need to do now is to open the terminal. How to open the terminal so that you can see what I'm doing. I don't remember the shortcut, so I need to do it manually. Yep. What I need to do is to send another post request, but this time I will send this request to the port 8888, which is the config server. So now you can see how we are dealing with the scalability issue. We are always sending the refresh request to the config server, and the rest of the job will be done by the config server itself. It will propagate all instructions. So let's send this. And one more thing is that in the body of this request, I'm telling my config server which application I want to reload. Okay, let's wait for the response. Yeah, it takes quite a long time. But what you can see here in the response is that config server tried to reload applications with names that match these two masks, and we are interested only in the customer-manager. But let's see what happens in the consumer. I don't know if you see it. So what about this? Yeah, what you can see here is that the event that was sent by our config server is called refresh remote application event. We have also some timestamp. We have also information about the origin service. You can see that this request was sent by the config server running on port 8888. And what's also interesting is that our customer manager sent a response called ACK remote application event. So it told us back that everything worked smoothly. All right. To be sure that it really worked smoothly. Let's ask again for all our premium customers. And now I expect to get only those that whose email addresses end with gmail.com. And this is it. All right. Summing up, during this presentation, you can see how complex and how confusing configuration issues may be. I agree that keeping properties and YML files outside your code base is a good thing, but it just might not be sufficient in distributed environments. And in order to solve those issues, we can use config server with Git as backing service. Then, and also with the help of Spring profiles, we keep our applications environment independent. We keep our configuration outside of deployment bundle. We deal very easily with scalability. We get security. We get traceability. All the problems that we identified at the beginning, we just solved with this. And the one thing that I didn't mention, but I want to do it now, is that to fully automate this process, we can set up a webhook on our GitHub or whatever Git provider you like. We can set a webhook that would send a request, a post request to our /monitor endpoint in our config server that will be invoked whenever any change is pushed to our remote repository, so that our process is fully automated and we won't need to do anything by ourselves. And you should always keep in mind that software development is about trade-offs. So before you decide to go for this solution, you can think carefully, because it solves the issues, but it also has its drawbacks, because it complicates continuous integration and continuous deployment a bit, because now we have a second place apart from your local files, the second place where you keep configuration. So it may be tricky a bit, so you need to bear that in mind. And at the same time, you also need to choose the strategy about how you store configuration in your backing service, where you use one common repository with application-dependent folders like I did here, or if you want to choose one repo per profile, one repo per application strategy. It is up to you, but the decision is very vital at the very beginning. Thank you very much for attending. I'm really glad that you came to see my presentation. I will be hanging around here today, and I will be also here tomorrow. We can go for a beer now and have a chat. I will be more than happy to answer your questions. Thank you very much once again.